what are endocrine disrupting chemicals for you?
Yeah, so these are chemicals that interfere with the way that hormones act in the body, very simply put. Now, in more depth, thinking about them, they could be chemicals that mimic hormones of the body or block the actions of hormones in the body. They could be chemicals that alter our ability to produce hormones or break down hormones, or transport hormones to their targets within the body. To date, most endocrine disrupting chemicals that have been identified are chemicals that mimic estrogen, block androgens, or alter thyroid hormone signaling. But the endocrine system is much more complex than that. And most of those chemicals have been identified in those three general buckets because that's where we've looked. As we've developed methods to look at other hormone systems and other actions like hormone synthesis, we're starting to identify chemicals that affect those pathways as well. If we think about the relationship between exposure and effect, if we're talking about something that's just strictly poisonous, we would expect that with greater exposure, we see greater effect, right? So if you take a drink of alcohol. Many of us enjoy a drink of alcohol in the evening, and it has a little bit of an effect on us. And if you drink more alcohol, it will have more of an effect on you. And if you drink an excessive amount of alcohol, you'll slip into a coma, and as the levels build up in your blood, you can die. That is what we would expect with a poison. And it's that relationship is a pretty linear relationship. More of exposure equals more of an effect. But hormones actually don't act that way in our body. So our bodies are pretty good at maintaining hormones within some reasonable range of level in our blood. And so if you have too little or too much hormone, then you should expect to see adverse effects. So for example, if your body doesn't produce enough estrogen, you can be at risk for not being able to get pregnant. But if you produce too much estrogen, you could also be at risk of not being able to maintain a pregnancy or other adverse effects. So really, it's somewhere in that middle dose range that's actually perfect for our physiology. And our bodies do a pretty good job of trying to keep us in that range of what is healthy for us. Of course, there's endocrine pathologies where that balance is disrupted. So diabetes is an example of this, where your own ability to maintain blood sugar is affected, and it goes outside of that range of what is physiologically healthy. Endocrine disrupting chemicals also have these non-monotonic relationships between the amount you're exposed to and the adverse outcomes that are seen. So what we might see at low doses could be a disruption to fertility, and we might not see that same effect at higher doses. There's a lot of explanations for why this could be. And one of the simplest explanations is that hormones act by binding to receptors. And the typical metaphor is thinking about them as a key that fits inside of a lock. If you have a small amount of key that's fitting into the lock, hormone that's binding to its receptor, you can get one set of outcomes that happen. But if you start to add more keys into the system and more locks that are bound, it actually can trigger whole other pathways of effects. And that's why you might see very different effects at low doses than what you see at high doses. When we think about endocrine disruptors, at low doses, they might be mimicking the hormone. So you're going to be seeing one set of outcomes that are related to that chemical acting like a hormone mimic. And then as the endocrine disruptor exposure increases, you might also see toxic effects because at higher doses, it's starting to act like a poison in your body. So these are just a couple different ways in which an EDC can produce those non-monotonic relationships.
And those non-monotonic relationships, how often do we see that that endocrine disrupting chemicals would maybe produce those in a human body?
Yeah, so we have seen non-monotonic relationships in human studies. I think more than 10 years ago, we documented them for about a dozen different chemicals with a bunch of different outcomes. The challenge in human studies is whether they're designed to actually see those non-monotonic responses. So it's actually much more common to see them in studies in the lab, where you're purposefully exposing cells or creatures to increasing doses of those chemicals. And in those cases, I would say that non-monotonic relationships are incredibly common, incredibly common. And because of that, we need to study low doses differently than we study high doses. So, and this brings me to that other concept of low dose effects.
Mm-hmm.
With endocrine disrupting chemicals, just like any other toxic chemical, if you force feed these chemicals to rodents at high doses, they can be toxic, right? You can see actual death. That's not terribly relevant to human exposures, because unless a person, falls into a vat of a chemical, which could happen in an occupational setting, but would be very rare, you're not being exposed to enough of these chemicals to be overtly toxic, right? They're not making you sick, or they're not killing you. They're contributing to disease and to disease risk, usually over a period of years or decades. And so the effects that we see at low doses are often very different. And so we have to think about that if in a rodent, what we're studying is looking for death or overt signs of toxicity, but in humans, what we're seeing is disease. We're looking at apples and oranges. And more, I think there's a realization that we need to study animals at the similar or low doses that are relevant to humans, and look for disease outcomes, not just what kills or maims those animals.
And so you are actually also saying that a lot of these experiments or the classical toxicological experiments actually start with too high of those that are maybe not really relevant for human populations, and that we actually have to start new experiments, or what are other maybe experimental biases that we encounter now?
Yeah, you should be picking doses when you're studying chemicals that fit the question that you're trying to answer. So if your question is what kills the animal, you're going to have to look at high doses, because again, most of these chemicals, compared to botulism, right, they're not toxic. So you're going to need to expose creatures to high doses to see what kills them. That's not a terribly interesting question to someone like me, who's trained as an endocrinologist, because I'm not interested in what kills. I'm interested in the kinds of doses that, for example, alter a female's ability to make milk. So, if we're studying maternal health, of course, a mama who's too sick to be able to take care of her babies is important, but not terribly relevant to people. A dose that interferes with milk production, that's what I'm interested in. And we're more likely to see those effects at the lower dose range, where these chemicals are acting like hormones, than at the high dose range, where they're just making moms sick. And again, I'm not saying that those aren't important questions. It's that we have to design experiments to answer the questions that we're actually interested in.
That's maybe also relevant to this current situation in Belgium, because we're also experiencing the PFAS, or more explicitly the PFAS problem here, where we find what some authorities say minimal amounts in soil and blood, even of the general population. But you are saying that even these minimal amounts could have effects on hormone action in the human body then.
Yeah, that's right. I think that the more we study particular chemicals, PFAS are some of them, lead is another one, the more that we realize that the exceptionally low doses, exceptionally low exposures are still affecting health in an adverse way, which leads us to the obvious conclusion that for many of these chemicals, there really is no safe level of exposure. And really, allowing people to be exposed to those chemicals means that we are accepting the consequences of those exposures. In the case of lead, the consequences of those exposures are lost IQ points and disrupted brain development. And again, we're not talking about death. So we're talking about lost productivity. We're talking about lost potential in children's brains, and that's that's a question of what we value
Hmm.
and what we're willing to give up in order to protect children's health. Because ultimately, children's health becomes adult health when those children grow up and make less money and struggle to see their intellectual and human potential.
And specifically for endocrine disrupting chemicals, do you have some examples about endocrine disrupting chemicals that can act at low doses and how they affect hormone action in the human body?
Yeah. One of the best studied chemicals is bisphenol A or BPA. That's the first chemical that I started working on now 15 more years ago. And what we were studying when I was a PhD student was the effects of exceptionally low doses of BPA on the development of the mammary gland in mice and in rats. What we saw was that even at the lowest doses we tested, which was nanogram per kilogram per day exposures, so doses probably below human intake, even at those exceptionally low doses, we saw disruptions to mammary gland development. We saw precancerous lesions developing in the mice. And we know very well how BPA works. And we also understand quite a bit about how it's working and affecting the mammary gland in particular. But BPA has gotten a lot of attention because it's a chemical that mimics estrogens. And it's teaching us a lot about how even very low exposures, low doses to estrogenic chemicals can alter sensitive organs if you're exposed during periods of development. So it's quite possible that adults don't need to worry to the same degree as a fetus, but of course a fetus can't worry because a fetus isn't making choices. It's adults making choices about what fetuses are exposed to.
But I wanted to ask you, we've already talked about dose response curves and low doses, which are both relevant within endocrine disrupting chemicals and exposure to the human body. But I also wanted to talk about I think another really relevant subject, that's the mixture effect
Mhm.
or cocktail effect.
Mhm.
Could you maybe explain that a little bit?
Sure, yes. So, I study rodents in the lab, and that means that I can study chemicals one at a time. I purposefully administer a chemical to a rodent, and then I can compare that animal to a rodent that was not exposed to that chemical. This is not at all the human situation, right? We are living out in the world and we're living in a stew of chemicals, many of which, as just a person, I'm not aware of, I'm not thinking about. But we're being exposed to chemicals in food and food packaging and personal care products, from our built environment, from the pesticides that are sprayed in our neighborhoods or on our lawns or in our houses. So we are living, an example, each one of us, a cocktail effect. And as individuals, those cocktails are unique to us and our lived experience, but we can look at populations and come up with example cocktails that are fairly representative of populations. Um, the mixture effect is basically an understanding that because we're exposed to multiple chemicals, they're acting in our bodies collectively. And in some cases, they're acting in ways that add up. So, we're exposed to all of these chemicals at teeny tiny little amounts, but all of those teeny tiny amounts add up to something. And so there's additive effects of chemicals. There's also this idea that some chemicals in our bodies might act synergistically, so that being exposed to multiple of those chemicals, where you have a little bit of this and a little bit of this and a little bit of this, doesn't equal, a modest effect. It actually creates this synergistic outcome, this greater than expected outcome. There's also an issue that has gotten less attention, but I think is very important, which is the idea that many chemicals could act in very different ways. So they don't have the same mechanism. They're not all binding to estrogen receptor, or they're not all altering your body's ability to make hormones, but they're acting on the same outcome. And because they all act on, for example, testis function, they do it differently, but they're all hitting that same outcome, that you could end up with a mixture that has totally unanticipated effects from that, from all of those different hits coming in different ways. And this has been documented really in rodent studies. And there aren't a lot of them because studying mixtures is complicated and expensive. And developing the statistical tools for evaluating mixtures were really at the beginning of that field. But what we have seen in cell cultures, in animals, and in human populations are these additive or synergistic mixture effects, this cocktail effect. Where that becomes really complicated is when we're trying to extrapolate from the rodent to the human situation. Because again, like I said, in most of our controlled lab studies, we're studying a chemical at a time, or sometimes we're studying 2 or 3 chemicals. We call those mixture studies. They're not really sufficient to be able to understand the full human experience. What I think, though, if we're thinking about public health and protecting humans, is that whatever we see in animals with 1 or 2 or 3 chemicals, we should expect the situation is likely worse in humans that have this other background exposure to other things that we don't fully characterize or understand.
Because the amount of chemicals like EDCs that we're exposed to is much more than 3 or maybe more than 10, and a whole lot of products probably.
Yeah. So, there's been some studies that have tried to just count how many synthetic chemicals are found in amniotic fluid or in cord blood, or in, baby's blood at birth. And the answer is in the hundreds. And the problem with those studies is they only look for what they know to look for. So it's hundreds of known identifiable chemicals in those babies. There are all kinds of unknown, unidentified chemicals that, right, again, you don't know what to look for if you don't know what to look for. Yes, all of those chemicals are not endocrine disrupting chemicals, but if they're acting on the same outcome, right? So lead is an endocrine disruptor, but most of its effects are as a neurotoxin. But if you're exposed to lead, which is a neurotoxin, and you're exposed to an endocrine disruptor that's a neurotoxin, it doesn't matter that one was an endocrine disruptor and one wasn't. You've now got a compounded effect on the brain, and it can't be ignored.
Okay. And so in a situation that we're in our everyday life are exposed to those background amounts of endocrine disrupting chemicals, and then we come into a context of a workplace, and where we also come into contact, how easy is it then to calculate or foresee the possible physiological consequences of all those substances interacting in the human body and interacting with hormone action?
Right. Yeah. I mean, the work environment is such an interesting one because, in my view, it's relatively understudied for how important it is as a point of intervention for potentially vulnerable people. And in this case, I mean vulnerable because of exposures, not vulnerable because of physiology. Again, I think many times historically workers have been seen as the least vulnerable because they're adults, they're often male, they are provided some level of knowledge or information about their exposures, and then it's kind of on them, like, oh, you didn't wear your PPE properly, well, you should have. And so I think, workers are vulnerable because of their employment status, right? So are you going to speak up if you're going to get fired? And the answer is often no. So you're vulnerable because you're dependent on the person or the group that's exposing you to the chemicals. You're dependent on them for your livelihood. But you're also vulnerable because you often have exposures that far exceed what would be seen in the general population. PFAS is another really great example because it in the United States, again, there were some lawsuits for focused on industries that had polluted surrounding communities with PFAS substances, and workers were actually enrolled in epidemiology studies because they were known to be the most highly exposed based on their workplace environment. And so they're called the C8 worker studies. And so they could compare workers in that environment with people living in neighborhoods who are more heavily polluted and exposed than people where I live. And so they could compare those three populations. And in that case, they treated the workers as sort of the signal for what would likely show up in other populations. It would just show up faster because you've got this higher exposure, so you're more likely to detect the signal. And they found all kinds of health outcomes again in those workers, including a higher risk of cancer, which I would say is it's too late at that point. How many generations of workers were exposed to those chemicals, and the companies should have predicted that with proper and better testing. And I think the amount that any company has been tasked to pay as remediation is insufficient for the damage that they've done to their own workers, to their communities, and to the broader environment. But the opportunity to study those cases has been really important in telling us about worker vulnerabilities and the effects we can predict in broader populations. So the assumption that chemicals have thresholds basically is an assumption that at high doses, you're going to see some effect. At mid doses, you're going to see some effect. But at some point, you'll hit a dose at which you can no longer detect the effect. And that's the threshold. And so based on that assumption, if you expose people to levels below that threshold, you shouldn't see any health effect. This is really the way that our entire risk assessment process is designed, right? We often will do studies in animals where we'll expose them to high doses. We'll look for overt signs of toxicity. We'll use the dose at which we no longer see those overt signs of toxicity to say, okay, this is the no adverse effect level. And then we'll calculate what we think is safe for humans. The problem is that the way that those studies are designed is that they look for overt signs of toxicity, and then we get to human populations that are exposed to these low levels, and we see increased biomarkers for kidney function. Well, that wasn't looked at. Or we'll see, oh, you have it takes you longer to get pregnant than people who aren't exposed. Well, that wasn't looked at. Or we see, oh, you could get pregnant, but you couldn't produce enough milk for your baby. Well, that wasn't looked at. Or increased fibroid risk, or lower sperm count, or right, all these things that are super important to human health, but weren't looked at in those studies. And so ultimately, that doesn't mean for sure that there's no threshold. It means the way we calculate a threshold is entirely wrong. But having said that, for many of these chemicals, we can't find a threshold. because even when we look at very low exposed populations, we still see effects. And that's not surprising if we're talking about chemicals that affect the endocrine system. They're going to have effects at exceptionally low doses because exceptionally low doses of hormone are what do the job of hormones. But also because the whole idea of being able to find a threshold is really also around the idea of how sensitive is the outcome that you're looking at, and are you looking at a big enough population? So if I go look at a population of 50 people, I might not see anything, but if I looked at a population of 500 people or 5,000 people or 5 million people, I might suddenly have the statistical power to be able to see an effect that was always there. You just couldn't see it with only 50 people. Yeah, I mean, there are other problems with trying to extrapolate directly from a worker population to the general population, right? A worker population is often healthier than the general population. So you might not see it because people who become ill in the working situation drop out of the working situation because they're ill. So, there's other problems with saying because we didn't see it here, it means we won't see it over here. There's no children in the worker population, and oftentimes exposures that children are more sensitive. They eat more, they drink more, they breathe more air per body weight. So not seeing something in workers doesn't mean that something is safe for the general population, because the general population includes sick people, young people, the very old people that were not ever included in that worker population. So if
And
you
for
see an effect in workers, you should assume a worse effect in the general population. I think that once we recognize that something's an endocrine disrupting chemical, we have to acknowledge that it's not safe, which means that alternatives need to be identified. In some cases, that might not be possible, right? There may not at this moment be a substitute that has the same features, the same, right? We don't just use chemicals for no purpose. I'm not ignorant to think that, there's just some guy who's like, pumping out chemicals at a factory and releasing them into the environment. Chemicals are used because they convey purposes to products. And some of those purposes are really beneficial to us, right? We don't want to go back in time with medical equipment. We've made tremendous advances in who we can save and who we can rescue because of plastics in the medical environment. So I'm not suggesting that we go back to the technology of the 1800s, but we also need to acknowledge that once a chemical is known to be an endocrine disruptor, it means there very likely is not a safe dose for the entire population. There is not a safe dose. So we need to do risk management and risk mitigation strategies. Those chemicals need to be phased out when they can be. Alternatives need to be identified and evaluated properly. So we're not just replacing one endocrine disruptor with another one that we just didn't know was an endocrine disruptor, and then on and on and on for decades. So again, I know this is not an answer that people find really satisfying, but it's because we need a paradigm shift. And that paradigm shift needs to be an acknowledgement that there are some properties of chemicals that are unacceptable for use in the general population, and that if an alternative exists, we need to use it. And that sometimes the alternative is not a chemical to chemical alternative, but a technological alternative. So an example there would be those receipts that you get at every till or cash register or the ATM. Do I need a receipt every time I put gas in my car? I don't. I just don't. And if you do need one, do you need it to be paper? Is that actually something that's useful to you? Do we still have boxes of receipts that we keep for work purposes? I think most of us who need receipts if we're doing work, an electronic receipt is what we actually need. We have to take that piece of till paper and scan it for someone who actually is going to use it. So the technological answer is sometimes the better answer than the chemical answer. And I think we need to embrace that. And I think in some cases, we also need to embrace behavioral changes. And the example that I give all the time is that here where I live, there's a furniture store that advertises furniture that you can spill your pastrami sandwich on with mustard and ice cream on your sofa, and then just hose it off. And so you won't get stains. And I, having some knowledge, expect that probably those chemicals, the fabrics, are soaked in PFAS in order to be able to do that. I don't know which one. Doesn't matter. I don't want PFAS on my sofa. And so the solution is not to find a better chemical. The solution is to eat your pastrami sandwich at the table, the way that we did when I was a kid. And now I know I sound like an old lady who's talking about going back in time, but we have created problems that we did not need to create. And now we're trying to create chemical solutions instead of not having those same problems. And I think sometimes that's the solution. And if we told people that you can either have this sofa in your house and increase your children's cancer risk, or increase their risk of immune problems, or increase their risk of developmental disorders by even a small fraction, or you could eat your pastrami at the table, I would hope most people would choose at the table.
Yeah. But also, to be clear, that's also what you say about the general public is also true for the workforce. Also there's it's very, very hard, sometimes impossible to find safe thresholds. So we also there need a paradigm shift maybe.
I agree 100%. And the only thing that's harder about the workforce is that there we're not talking about whether you can eat a pastrami sandwich on your sofa. There we're talking about, do you have a job? And I don't want to be responsible for the destruction of industries, but I also think that we should be shifting jobs away from areas where we're actually poisoning people in the workplace towards the creation of products that are safer for people. Because yes, if we're detecting a signal from chemicals in the general population, we should expect that if we had a large enough group of workers, we would see effects in the workers, and I would expect we're going to see worse effects in the workers.
In your professional opinion, what kind of actions would you promote in regard of exposure to EDCs in a occupational health context? You talked about keeping information for a long set of time for cancers, but also now at a shorter time, in a shorter time frame, or or maybe specific on different groups of the workforce that are maybe more vulnerable.
Yeah, I think that number one, we need to actually bank biosamples from workers, and we need to do it in an intelligent way. So, as a scientist, there's so many interesting questions that I have, like how different is your exposure on a Monday morning after 2 days off from your exposure on a Friday afternoon after 5 days of working? So designing the studies to be able to capture what human exposures are and how they relate to the work environment, super important. And it has to be designed so that it's not intended to downplay exposures, right? You don't measure everyone at 7 o'clock in the morning on Monday after they've had 2 days off. Certainly not for chemicals that are metabolized faster. We need to make sure that if men and women are both present in the workplace, that both men and women are evaluated. We need to capture health outcomes for those workers, and I think that great studies would follow them long after they stop being workers, to be able to see whether their risk of disease increases after that work period. Another thing is that, so when we think about workers, I think sometimes we immediately think about people who are working in the factory producing the chemical, like the powder of the chemical. And we're not also thinking about people who are construction workers who are exposed to chemicals in their job, or farmers who are spraying chemicals. And so we need to think about work in a broader way. And we need to recognize that that people don't use PPE the way that we ask them to. Right? Like if you're not standing over them, and I'm saying this because I work at a university, and universities are these great construction sites. There's always work that's ongoing. So we get to see workers in their environment as they work. They don't wear their PPE properly. It gets in their way. It's uncomfortable. And so we need to actually evaluate the use of those PPE and improve them. In some cases, we're using PPE technology that's 30 years old. So we haven't advanced the PPE at the same rate we've advanced the other technology that is what's harming them. We're not advancing the protective measures as quickly. And we need to stop holding workers accountable and start holding employers accountable. So, if there's a reason why workers aren't wearing their respirators, and it's because the building is so hot that it's not comfortable to wear a respirator, that's not an individual person's responsibility. The individual worker can't turn down the thermostat. That's an employer's responsibility. So it takes time and it takes trust building to be able to get workers to tell you where the gaps are in their ability to protect themselves, in order to actually do interventions that work, instead of just assuming I gave you a face mask, it's your problem if you're exposed, because it's not. It's all of our problem, right? We're all part of a society in which we all have to work. And so we shouldn't be saying that some workers are worthy of these nasty exposures if I wouldn't accept that myself while sitting here in my office at my desk.